this one. Okay. Today we're going to, let's see, this one right here. Yep. We're going to do this problem. So this problem is the 2012 problem number 5, no calculator allowed. This is differential equations. And we have to solve different questions here. Now, the problem says, the rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t0, when the bird is first weighted, its weight is 20 grams. If B of t is the weight of the bird in grams at time t, at time t days after at its first weight, then dB dt is 1/5 100 minus b. Let Bt the solution of the differential equation above with the initial condition B0 equals 20. That is the initial time here, the initial weight here. So this is A. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Explain your reasoning. Okay. After all these things, so the only you know is you have a function. Let me just put right here, stop. Yep. So you have a function b of t, that is weight, correct? Is weight. So t is time. And you know the differential equation this function solves is dB dt equals 1/5 100th minus b. So the function, the rate of change of the function is proportional to the function, you see? So the rate of change this bird gains weight is proportional to the weight at that moment. You see that? So this is what it means. Okay, so the first question is A. This is the bird gaining weight faster when it weighs 40 grams? For faster means the dB dt, when you evaluate in 40, right, is greater than dB dt when t is 70, or vice versa. So this is what we have to prove. This is because it says, is the bird gaining weight faster than when it weighs 40 grams than when it weighs 70 grams. So this is the rate of change the bird gains weight. Okay, so if you have to prove that one, Rangel, what you have to do? Let me just write it here. dB dt at t equals 40 less than dB dt at t equals 70. So how do you prove that? What you do, you have to prove that one. So this is faster than this, correct? And this is faster than this. So what you can do?
Evaluate. Evaluate?
Evaluate what? This function?
Yeah, can you graph it?
Okay. So, so here is the point, right? So evaluate, this is as t equals 70. So you said evaluate, but it's okay. I have dB dt at t equals 40 is going to be 1/5 100th, right? Minus b in 40. And dB dt at t equals 70 is 1/5 100 minus b in 70. Okay, this is correct, but I have a problem. What is this? How do we know that?
The derivative?
With the derivative?
I think.
I will check this one. So this is what we have to answer. This is the equation. This is the solution. Okay. So the situation is this one, right? you have to know in what time, and what, well, not what is, this is weight 70 grams. This is weight B. Yeah. B is the weight in grams at time T. This is B really. This is B and this is B. Okay. B and B. 70, B equals 40. So, well, that's right. This is B of T and this is B of T, correct? I don't know exactly at what time this bird is going to be 70 or 40, but I know that this is 40 and this is 70. So if you evaluate what you get, okay, 1/5, 100th minus 40, and this is 1/5, 100 minus 70. Okay, now what do you think? When is faster? Hmm?
The first one.
The first one? Okay, vamos a ver. 100 minus 40.
60.
Okay, yeah, according with this is 60 over 5, correct?
Yep.
And this is 70, 30 over 5. Now, which one is faster?
The
40.
first one.
The first one, correct? So how do you write your answer? Albert, tell me your answer. What would you like to write? Just explain your reasoning. My reasoning is this, correct? So I have to check if this, when B is 40, the weight is 40, or the weight is 70, what rate of change is faster, correct? Entonces, what I do is evaluate the thing, and I get that. So 6 over 16, 60 over 5, 30 over 5. So it's okay. Yeah, this is greater than this one, right? So your conclusion is what? You have to write something in the context of the problem. So what would you like to write? It's a very simple phrase.
Just the equation.
No, you have to write something here in English, your conclusion.
Oh, in English.
Basically. So this is your justification, your math, correct? So you conclude that this rate of change is more than this rate of change. Now you have to explain or conclude in English in the context of the problem. So it's a very simple phrase. What would you like to write? It's very simple.
Because the rate of change up 40 grams is faster?
Yes, is greater than, correct?
Greater than.
So the bird gains more weight when it's 40 grams than when it's 70 grams. And that's reasonable. Okay. One of the problems you're going to have in the test is check if your answer is reasonable. But think in a baby. A ver, Areli, you babysit babies. When the babies gain weight faster? When they are between newborns and 6 months or after 6 months?
After?
When they, after?
Well, I mean, from what age to what age do you say after?
Be careful.
6 months to like 5 years is a lot, but
yeah, but I mean in the same span of time,
okay.
Newborn to 6 months and 6 months to 1 year, in what moment the rate is faster? So they gain weight faster in the first 6 months or in the last 6 months?
The first 6.
In the first 6, it's always the same. Usually in the first 6, they double the weight. In the first 3 months, possibly they double the weight, correct? So you know that they grow fast. They can born very little, right? And in the first 6 months, they easily double the weight. That doesn't happen here in the second. So it's the same in the birds. When they are very tiny, they eat very much. So they grow very fast in the very first days. Is when their weight is low. Okay. So just think about it. You have to connect. So you have to think, how can you pretty much think that your answer is reasonable? Okay. Next question. Right? Let's see. The next question is, find the second derivative of b in terms of b. Use the second derivative to explain why the graph of b cannot resemble the following graph. And it's this one, right? So this is, find this one in terms of b, and then use this, the second derivative you find, to explain why the graph of b cannot resemble the following graph. Okay? Well, let's find the second derivative. That's the easy part. So we have to, using this, let me just erase this portion right here. Yep. So let me just put here b of, well, just put this is b of 0 equals 20, correct? So this is the initial condition. We're going to use that later. So I need the second derivative, correct? How do you find the second derivative? This is, well, what I know is this one. So I have to get this one. Remember, b is a function of t, correct? So this is okay. Let's see the second derivative. So I have this one. How do you get the second derivative? It's okay. Let's do this one. dv dt is 1/5 100 minus b. This is what I have to find. So let's see this one. How much is this one? Is 1/5 derivative of the 100th and derivative of this. What do you think? What is the derivative of 100th?
0.
And dv dt, correct? Now, this is going to be simply negative 1/5 dv dt. Now, you are going to, listen, you are going to express in terms of t. So this is dv dt, so you're going to put this one. So this is going to be negative 1/25, or let me just put it explicit, 1/5 times, parenthesis, 1/5 100th minus b. So this is the meaning to express the second derivative in terms of b. This first derivative is in terms of b. The second derivative has to be in terms of b. Okay, you take the derivative, you get this one, this is 1/5, this is a 0. So this is dv dt. Now, dv dt is this thing, so you have to plug in back, and then you have the second derivative of b dt squared equals negative 1/25, parenthesis, 100th minus b. Okay, now, this is the calculus, right? Now, we have to try to interpret this thing, correct? Yeah? And we have to know why, right? This is, find dv dt in terms of b. Okay, we solved this one, so this is possibly 1 point. So you have 1 point already, right? But now you have to interpret the derivative. Use the second derivative to explain why the graph of b cannot resemble the following graph. And this is the graph right here. This is this is right here. So how can we explain Let me just put it right here. Let me just try to sketch the graph. So it's 20, here is 20. Let me just sketch this graph. This is 100. And then the graph, 20, is something like this. Okay, this is time. Okay, let me just go back to the thing. So this is the point. What do you think? So why this expression is not consistent with this curve?
Would that be mean again?
Which one?
B, yeah.
B is the weight. So the second derivative is proportional to the weight gain, the way this gains weight, correct? And this is weight. So technically, this is B of t. This is B of t. This is B of t. We don't have any other information here. We have time in days. We don't have here the 40 and the 70. We don't know anything. So this is a blank axis. This is only the weight. So the bird begins at 20 and then at the end reach 100 is what this graph is going to say. At the end of certain amount of time, reach 100 grams from 20 to 100. So it increases its weight 5 times, right? Now, this says that at the beginning, this weight is very, very, very slowly, and then begins to gain weight rapidly, and then it stops. So this is what this graph says. At the beginning, in this interval of time that is kind of long, the bird practically doesn't gain any weight. You see, it's almost 20. After a certain time, you inflate the bird. You see? You are inflating the bird in a very short time. And then after that, the weight is practically steady. So this is the interpretation of this. What is this one? Check this. Check this. What do you think? This is not consistent with this. Why? So did you get the reading of this graph I made? Yeah. If you see, here is almost 20, you see? In this interval of time, the gain is practically nothing. Then in a short time, the bird grows a lot. Then the weight is steady. Do you think it's the way the birds are going to behave? So no complex math, just reasoning. What do you think, Arely?
Can I look at the question one more time?
So this is the question, right? This is, find the second derivative in terms of B. So we did it. Use the second derivative to explain why the graph of B cannot resemble the following graph. Now, remember what I said here. Okay, again, I'm going to repeat. So in this portion, right? In this portion of the graph, you see in this one, you see the bird practically doesn't gain any weight. I don't know how many days are these, correct? But assuming that this is the 100, it's pretty much, if these are, suppose these are 30 days, 1 month. So these are like 10 days, correct? These are like 10 days, these are like 10 days, and these are like 10 days, correct? Let's suppose that. So this graph says that the bird in the first 10 days is not gaining any weight. In the second 10 days, you inflate the bird, you see? After that, the bird weight is steady. It's practically nothing, right? No gains, correct? So you think this graph is reasonable?
No.
No, because you know that if you see this one, if you see this graph, when B is 20, the rate of change is 80/5. It's the highest. So the slope of the tangent line is very, very, very sharp. Then as you approach 100, this goes decreasing. So pretty much the behavior is something like this, correct? So in the beginning is high and then decreases, correct? Now, how do you know this one here? It's the same, right? It says that the rate of change is increasing very high when the t is 20. So when the weight is 20, this is also, let's see here. Let's go back to the, let's go back to the, right here. Oh man, stop sharing, right here. Let's see this one. When the B is 20, this is 80/25. When you increase this one and you approach to 100, this decreases. So this means that the rate of change is higher when the weight is low, correct? So again, this graph has to be something like this, correct? So it's very high. The very early days, the bird gains weight very fast. Then when the time begins to decrease. This is not consistent. Okay, a ver. Everybody catch now the explanation?
Yep.
Okay, well, now, in your own words, how do you explain that? So remember, when B is 20, this is 80/25. When this is 40, this is 60/25. When this is 50, this is 50/25. So as you gain weight, this decreases, correct? See, this is smaller, correct?
Yep.
Okay, so a ver, try to write something to explain this thing. Remember that this is going to be critical in the AP test.
The values of the equation don't match up with the values of the graph.
Of course they don't.
No, I know, but that's what we're gonna write, right?
Sí. So, mira, all the secret is right here, Rangel. Yeah. Reading a graph is something that you are going to do in your professional life. If you see the behavior of data, so you should be able
to write it out.
Okay.
So,
okay. So in this portion, this graph indicates that in the first days of the birth, and in the first days close to the date of birth, correct? The gain is practically zero. This equation says that the rate of change is the highest when the B is 20, because this number is the greatest, correct? You see? Same here. The rate the bird gains weight is more when you are 20 than when you are 30, than when you are 40, and so on. So this is not consistent, correct? This graph is not consistent because this graph says that the bird gains weight very slowly in the early days, opposite to this, and opposite obviously to this one, because this is the rate of change of this rate of change. And this number is bigger when the B is 20 than when the B is 40. Now, you see that?
Yep.
Okay, well, think about it that this is possibly a problem that you have to explain. Okay, let's go to the next questions. We have to speed up this thing. So we have here, okay, let me just delete this, right? And then the last question is, use separation of variables to find y equals b of t, the particular solution of the differential equation with initial conditions b20. Okay. Now, I want you to solve by your own this equation. You solve this equation when the b is 20. Remember, it's separation of variables.
$16.
Okay, let's see. Vamos a ver. You have to solve this equation by separation of variables. You have to find b of t, correct? Now, we're going to know what function is this. Now, this equation, the b is in this side and the b is in this side. So all the b's has to be together. So what I'm going to do is this one. db over 100 minus b is 1/5 dt. What I did, I moved this dt to the other side. You can see that. If you want to see like that, you move this to the other side, the t's, and then you move this to this side. What is the next step? The next step is integrate. dv dt of dv 100 minus b, correct, equals the integral 1/5 dt. Now, this is going to be from 0, and this is going to be b of 0. And let me just change the variable to s, and then you put here a t. It's just, you know, okay? You know. And this one is b of t, correct? b of t. Okay, and let me just change the variable also to s and to s, just to be consistent with the calculus, correct? Let me just write this in better handwriting. Yeah. So is the integral b of t vs over 100 minus s b of 0 equals the integral from 0 to t 1/5 ds. Okay, what is this integral? What is this integral? Yes. A ver, you remember this one? This is a basic integral. Vamos a ver. Let me just share the screen. Yep, right here. Right here. Let me just go to the integrals. Right here. Okay, which one of these integrals looks like that one? This one, this one, this one. Which one? This one, right? So you have the integral du over u equals ln absolute value of u plus c, correct? And the other one is simply the integral du equals u plus c. Okay, let me just show you here. These are the two integrals to solve this problem. So this is like this one. This is 1 over u is just shifted a little bit, correct? And this is the du. So this is this one. So what is going to be the solution of this one? This is okay. If we solve the calculus here, so the first one is negative ln absolute value of 100 minus s evaluated from b0 to bt, correct? Equals, equals 1/5 of t s evaluated from 0 to t, correct? So this is the solution of this, and this is the solution of this. Why the negative? Because when you get this derivative is 1 over this times the derivative of this, that is -1 times a negative is a positive. So you're going to have negative ln, parenthesis, 100 minus b of t, correct? Plus ln of 100 minus b of 0, but b of 0 is 20. So I'm going to put here 20 equals 1/5 of t, correct? Is what you have. So everybody's catching up this one. So it's just, I have to find who are the antiderivatives of these two. For this is this one, for this is this one. Now it's a definite integral, so I have to evaluate this in the limits of integration, same as this one. So it's ln of, yeah, s, right? B here and B here, so is this in BT minus, but here I have a minus here, okay? Negative times a negative positive, 100 minus 20, 150, correct? Okay, now what? So, okay, this is 80, correct? So this is 80 minus ln of 100 minus b of t, right? Equals 1/5 of t. Now what you can do, you can move this, or you can put this in this side, so you can have ln 100 minus b of t equals 80 minus 1/5 of t. So I just mixing my things, putting together. And how do you remove this one? Really, this is well, this is algebra. Let me just put it with the algebra one, with the algebra, with black algebra. So this is 80 minus ln 100 minus b of t equals 150, and then I have ln of 100 minus b of t equals 80 minus 1/5 of t, correct? How do you remove this with the exponential? So you have in 100 b of t equals exponential of 80 minus 1/5 of t, right? And what is the final solution? B of t is what? Is 100 minus e, 80, e to the 80 times e, let me just put it right here, e to the negative 1/5 of t.
Why did he split up the e's?
I can, but if you don't like it, we can leave it like that. Yeah.
Oh, okay.
It's not a problem. Yeah. So, let's check this one again since the beginning. You have this differential equation. This is your initial condition, so you need a solution. Okay. We have to do separation of variables, so I have to put all the b's together and all the t's together. So I just move this to the other side, this to the side. Then to remove the differentials, I have to integrate, correct? Now I'm going to change the variable of integration just to avoid confusion. So this is going to be from b0 to bt, from 0 to t. So you see they match the limits of integration. And I change the b's by s. So that's just a formal change. Now, derivative, the integral of this is this one. This antiderivative is this one. This antiderivative is this one, right? And if you plug them, you have to evaluate in the limits of integration, correct? Okay, then you put this right here minus this right here. You get this. It says 1/5 of t minus 1/5 of 0. Then you do your algebra, you solve, and then you get your function, correct? Let me just put it better. This is E 80 minus 150. So that's my answer. Okay. Let me just see this one. Oh, this is ln of 80, sorry. This is ln of 80. This is ln of 80, correct? And e to the ln of 80 minus this one. And here, I'm going to split 80 e negative 150. What I did, if you split this one, e to the ln of 80 is 80, correct? Now that's the answer, sorry. It's because I forgot, when I erased, I forgot to put the ln here, this ln here. Okay, any question in this point? Yep.
Yep.
Everything okay? Okay, let me just, no question, Rangel?
Nope.
Okay, now, important. This problem was repeated in 2 previous years. I'm going to show you, check. So we're going backwards. So did you see this is the problem for 2012 and the problem for 2011 looks pretty much the same, you see? Yeah, you have again pretty much the same. dWdt 125W minus 300, and then you say find the second derivative, use the second derivative, right? And then find a particular solution to the differential equation with the initial condition, this one. Okay, because we are almost at 12, right? I would like you to try C. It's practically the same we did before, okay? So let me just write it right here. And then tomorrow we do the other 2 questions, correct? So we have dw dt equals 1/25 of, this is w minus 300, right? This is w of 0 equals 1400. Okay? So I want you try this equation in the next, it's exactly the same as before. So the same as the other one. I want you to do this one by your own. Okay? Okay.
Okay.
So if you check this equation, looks exactly the same as the other one, right?
Yep.
Except that these are flipped. But the idea is the same. So I will try the same and find the answer before I do something here.
Wait, like right now?
Yeah, right now. In 4 minutes, you can do this.
Okay. Ah, all right. Let me get like
Because it is the same as the other one. You do the same
Yeah.
step, you use the same integral, you have the same answer. Are you in that step?
Yeah.
Okay. Now you have to substitute. No. Yes. Now you know how much is 100, this one. So this is And the answer is you found the same answer?
You got there before me.
Okay.
But yeah.
Okay, muchachos. You see, differential equations is not a bad topic, it's nice. I want you to remember this. This is going to be your life in college. Is what you're going to be solving always, differential equations. Okay? It's very important you understand that. Of course, these are simple differential equations that you can solve with calculus, right? But the ones that are going to be difficult, you are going to use programming and numerical methods to solve them. Okay? Okay, guys.